This is the Beelink EQi12 featuring the Intel Core i5-12450H CPU. Now let's go ahead and take a quick look at the mini PC. And actually, before I do that, I want to give a huge thank you out to Beelink because they did provide me with this review sample free of charge, so many thanks to them. And if we take a look at the device, you can see it's an all plastic enclosure. And taking a look at the ports, you got a USB type A and a USB type C port in the front here, and these are USB 3 ports. So this is not any kind of display out, or you can't power the device through this USB-C port, but they are both 10 gigabit USB 3. Then you have your headset jack, a CMOS reset button, a power button, as well as a status light there. And then going ahead and looking at the back of the additional ports, you can see we've got 3 more type A USB ports, and these 2 here are 10 gigabit ports, and this one you can see here is rotated at 180 degrees. This one's actually a USB 2 port, so it'd be good for like a dongle for a keyboard or mouse. Then you've got 2 full-size HDMI ports, which should be able to provide up to 4K 60 output out of both of those. Then 2 1 gigabit Ethernet jacks. And a little bit disappointing offhand here is that they don't have like a HDMI and a display port, neither here nor there. And these are also 1 gigabit ports, which this day and age, I think anything new released should actually come with 2.5 gigabit ports. But more importantly, which I think is really interesting about this device, is that it actually has an internal 85 watt solid state power supply. We'll go ahead and take a look at that later. So essentially you don't need a unwieldy power brick or wall wart in order to power this device. And so it does come with this power cord here with just the 2-prong power plug here, and then you plug it directly into your wall. And then you've got your cooling fins in the back here to pass air over it to cool the CPU. Taking a closer look at the bottom here, you've actually got some additional vent holes, then 4 screw holes here. Now, the interesting thing is that these screw holes actually had these plastic plugs over them, or rubber plugs, and I'm not sure why, because obviously it's aesthetically it makes it look better, but it's going to be sitting down, you're never going to see it. And then they intend for you to get access to this bottom panel here so that you can actually access the M.2 SSD slots. But once you remove the 4 screws off the bottom here, they actually have this handy little pull tab, so you can just pull it up and then access the internals of the device. Now with the lid off, we can go ahead and take a closer look at the components in here. And here we have a Wi-Fi card, which is an 802.11ax or Wi-Fi 6. And it is in an M.2 Wi-Fi 2230 slot, which is probably a an M.2 type E slot. So you could use some sort of adapter to go to a type M slot to add an additional SSD. And I'm actually going to try that. So using something like this with a 2230 SSD in there. And then this is a type E slot to a type M slot. Just plug it in there, and then you can make room for an additional SSD if you sacrifice your Wi-Fi slot. Now we go ahead and take a look at this big heatsink here. Now this is to cool the 2 M.2 SSDs that the system can accommodate. Now this particular model only came with a single 500 gigabyte M.2 SSD, but you can clearly add a second one if you want to, or obviously replace the existing one as well. And then lastly, we've got the power supply, which is right here. And I'll go ahead and take this lid off later so we can take a closer look at that too. Now I'm going to go ahead and remove these screws so we can remove the heatsink for the SSDs. And there's the heatsink. You can see you've got these pads here that touch down to the SSD controller, because that's typically what gets hottest, so it dissipates heat through here, and then NAND chip may or may not touch down to the surface here, but we'll see how well it cools those. And then there's the SSD that it comes with, pretty much a generic no name, but you can see it's got the Phison controller. And we'll take a closer look once we get into Windows with Crystal Disk Info to see exactly what it is. And it looks like it has a separate daughter board here in order to create the ports in the front. So that's going to be another challenge there to get that removed in order to access the other side of the motherboard. Now one thing that I noticed that is blatantly missing from here are RAM SODIMM slots. And that's because this apparently has DDR5, 24 gigs of DDR5 soldered to the other side of the motherboard in the CPU compartment on the other side of this motherboard. So you're really kind of stuck with the 24 gigs that you're given. But for most people, that's probably going to be more than adequate. And I will remove this board later so we can get a closer look at the CPU cooling solution as well as the RAM. So now I'm going to button this back up and boot into Windows. Now another interesting selling point about this device is that it actually runs very quiet. Now I did do some initial testing and it does actually run quite quiet, although the CPU can run a little bit hot. But we'll take a closer look at those details when we get into Windows. Now before we boot into Windows, let's go ahead and take a look at the device itself on their website as well as the CPU. And here is the Beelink EQi12 with the Intel Core i5-12450H, which is the model we have. You can see here it comes with 24 gigs of DDR5 and 500 gigabyte SSD. And so the particular model that I have with this CPU selected, then 24 gigs plus 500 gigabyte SSD is $389 on their website. Or if you go to Amazon, you can see here it's $429 minus $50 coupon, so that's about $379. So actually 10 bucks cheaper than buying it directly from Beelink. Now if we go ahead and take a look at the Intel website for the Intel Core i5-12450H CPU, you can see it's a total of 8 cores with 4 performance cores and 4 additional threads. So that's 8 threads there. Then 4 more threads with the efficient cores for a total of 12 threads, 4.4 gigahertz, and a 45 watt TDP. And then it does come with Intel integrated graphics. Now this is not any kind of powerhouse for gaming or anything, but the Intel integrated graphics is actually great for just regular desktop work, as well as even transcoding things like Plex videos. The Beelink EQi12 comes with Windows 11 Pro pre-installed. Powering up the device for the first time and setting up Windows went through without any issue. It did not even ask me to create a Microsoft account. Now once in Windows, all devices on the device manager were accounted for with drivers pre-installed. It was a clean installation without any additional bloatware. Now considering what happened with Ace Magic and their mini PC systems that shipped with malware, just to be safe, I ran a full system virus and malware scan using Malwarebytes anti-malware and it came back clean. There were also no questionable folders on the C drive either. Once I connected to the internet, Windows 11 Pro was activated without a problem. After that, I then proceeded with a gauntlet of Windows updates without issue, and then following that, the Intel Driver and Support Assistant brought the Wi-Fi, Bluetooth, and GPU drivers up to date. Let's go ahead and take a closer look at the CPU. And Task Manager here, we've got the i5-12450H. You can see here a total of 12 total threads, but 8 cores, 12 logical processors, and I think it's 4 efficiency cores. And then memory, you can see here we've got 24 gigs of RAM at 5200 mega transfers per second. And then the SSD, which is we'll take a look at that in Crystal Disk Info. So here's the stock SSD that comes with the system. It's a Crucial CT500B3, 500 gigabytes only, but you can see it is a PCIe 4.0 X4 SSD, and there's the resulting performance in Crystal Disk Mark over here. So now let's take a quick glimpse into the hardware of this machine using HWinfo64. And as already mentioned, it's got the Intel Core i5-12450H, 45 watt TDP. The BIOS is dated June 28, 2024, version EQi12204. The RAM is the 24 gigabytes of LPDDR5 SD RAM, so it's soldered on, and it is in quad channel mode. Then we've got the integrated graphics here with 2 gigabytes of allocated VRAM. I believe that this is dynamically allocated as it needs it. Then we have the NVMe SSD listed right here. Now if we take a look at the networking of the machine, you can see here we've got the Intel Wi-Fi 6 AX101, so it is an Intel Wi-Fi card. And as far as the wired Ethernet, it is the Realtek RTL 8168-8111 gigabit Ethernet NICs. And then as far as audio, it's just the built-in Intel Alder Lake audio. So here's a quick look at the BIOS, and as we saw in HWinfo64, BIOS version is EQi12204, build date of June 28, 2024, Intel Alder Lake i5-12450H CPU with 24 gigs of RAM. Go over to the Advanced tab here, you can see we have all these options through here. Now one thing I'm not a big fan of is, in a lot of these mini PCs, they effectively have a fully unlocked BIOS, but doesn't necessarily mean that those options are tied to anything, so you can make a change and you're not sure if that is actually really affecting anything or not. But the one thing that I'm really more interested in is this hardware monitor. You can see here we've got CPU temperature, fan speed, and I can actually change the fan mode to full on mode, and so we can kind of check at the stock fan speed, which is very quiet, versus full on mode, which is louder, but see how that affects temperature and performance overall. See, if we go over to chipset here, we go to PCH.io, and here it shows even a SATA configuration. This device doesn't even have any SATA ports on it, so I'm leery to touch any of these other options. Secure boot, boot menu, and then save and exit. So in order to validate the performance of the M.2 slot, as well as check for the cooling performance, I'm going to be installing this SK Hynix Platinum P41 NVMe SSD drive because it can achieve about over 7,000 megabytes per second, pushing the limits of the slot. Additionally, I'm going to remove the Wi-Fi card and install this MP600 Mini in this adapter from a Type E slot to a Type M slot, and this is a PCIe 4.0 X4 SSD actually, so we'll see if what kind of performance we can get out of that slot there. So first the SK Hynix SSD, and now for the M.2 adapter from the Wi-Fi slot. And now for the M.2 2230 SSD itself. And there you have it, SK Hynix SSD and the 2230 SSD. Alright, so now we're back into Windows, and you can see here in Disk Management we have the 3 SSDs installed. Taking a look at them in Crystal Disk Info, the C drive is the stock CT500P3 that we already took a look at, and there's its resulting sequential read and write performance, 4900 read, about 4100 write. Looking at the D drive, which is the SK Hynix P41, 2 terabyte, you can see here it is configured as a PCIe 4.0 X4, and also it is a PCIe 4.0 X4 SSD, so it's operating at its full potential in there. And we go ahead and take a look at Crystal Disk Mark results there. You can see that sequential read and writes, the read is 7100 megabytes per second, and the write is about 6800 megabytes per second. So it's definitely pushing the limits of that PCIe 4.0 X4 slot. Now let's take a look at the Corsair Mini, which is in that Wi-Fi adapter. And you can see here it is operating in a PCIe 3.0 mode, however, and at only X1 lanes, even though the SSD itself is capable of PCIe 4.0 X4 performance. And we can go ahead and take a look at the performance here in Crystal Disk Mark, and it is hitting about 870 megabytes per second read and write. That's strictly due to the limitation of the PCIe 3.0 X1 slot. But either way, this might make good for a good boot drive or an additional storage if you want to, if you're willing to sacrifice your Wi-Fi card. Now, in order to check to see how well it can handle the thermals of a stressed SSD, I'm going to be doing a read test using Hard Disk Sentinel and monitoring the temperatures and performance as it goes throughout the entirety of the disk. I'm going to be testing all 3 of these drives, the stock CT500P3, the SK Hynix 2 terabyte, and then the Corsair Mini. So the stock SSD is finishing up the full disk read test here. You can see here it's maintaining about 5600 megabytes per second. Go ahead and take a look at the temperatures over here. You can see it's maintaining about 41 degrees Celsius throughout. So it seems like that big heatsink is actually doing its job. Now as this SK Hynix P41 is finishing up, take a look at Task Manager here. You can see it's using only about 80 to 83% of the SSD performance as it goes through the read test. And taking a look at the temperatures here, we have about 48 degrees Celsius throughout the test. So it seems like that big old heatsink for those SSDs is doing its job. Now as the MP600 Mini finishes up here, you can see here the temperature is right around 55 degrees Celsius. It's higher than the other ones only because it does not have any kind of heatsink on it, but since it's limited to only about 800 megabytes per second, it really shouldn't get much hotter than that. So it seems like it should be fine if you put it in there, but there is room to actually add a heatsink on that SSD if you wanted to. Now here's a quick validation of the USB ports on the device, and the front two, the USB-C and the USB-A, are both 10 gigabit, 1000 megabytes per second or so. And then on the rear, you've got 3 total USB ports, and the outboard ones are 10 gigabit. Then there's the innermost port, which is only USB 2, and so that's the performance you're going to get. Now let's take a quick look at the Ethernet adapters here, and you can see here we've got the Realtek PCIe Gigabit Ethernet Family Controller driver. So these are Realtek network adapters, and they are only running at 1 gigabit. I have an iPerf3 server that I'm going to go ahead and do a quick test on. And then I'm going to physically remove and install the network adapter on the other port, and go ahead and run the iPerf3 again. So it's running as it should be, around 1000 megabits per second. And one thing I'd like to note though is that I had to download the latest drivers from the Realtek website here, because when I would manually switch from one port to the other, it would not auto detect and it would have issues pinging the iPerf3 PC, and once I updated the drivers, everything seems to be working just fine. So now to test the wireless capability of this device, and we're connected to a Wi-Fi 6 router about 10 or 12 feet away, direct line of sight, Take a look at the specifications of the Wi-Fi 6 router. Here we're connected at 5 gigahertz with a maximum speed of 600 megabits, and so that equates to about 75 megabytes per second maximum throughput. And if we go ahead and take a look at the spec page for this particular model, it does show that it is a 600 megabit card. And so I'm going to go ahead and run an iPerf3 test here, see how it performs. So you can see there it performed at about 400 megabits, and that equates to, so 401 divided by 8, that's about 15 megabytes per second. So that's the performance you should see with this type of Wi-Fi card in a direct line of sight. And when running idle, the Beelink EQi12 only draws about 10 watts of power, and the fan is not audible at all with the stock fan configuration. "4K YouTube video streams smoothly with almost no dropped frames while drawing only about 18 watts of power." Both HDMI ports are capable of displaying at 4K 60 Hz. Now this monitor is only 4K 60 Hz capable, so I can't test any higher than that. That's port 1. I swap it over to port 2. Hard to do with one hand. And you can see there we're still 4K 60 Hz. Now I have this Beelink EQi12 PC connected to a 1080p 100 Hz monitor, but you can see here it will only go up to 75 Hz for whatever reason. So that seems to be the limit of this HDMI port. Next, I ran Cinebench R23 in order to stress the system, and the temperatures leveled out at about 86 degrees Celsius, with the CPU clock speeds averaging about 2.7 gigahertz throughout the test while drawing only about 65 watts of power from the wall. Using the stock fan configuration, during this test, the fans remained remarkably quiet even with the system fully stressed. While this really isn't intended to be a gaming machine, I did run a few game benchmarks set at 720p low settings, and it did manage to run older and less demanding games like Batman Arkham Knight, Hitman, Forza Horizon 4, but it was at a barely playable 30 to 40 FPS with drops down in the teens. And other games like Shadow of the Tomb Raider was not really all that playable, but Sleeping Dogs actually offered a solid 35 to 60 FPS gaming experience. And if you can see in this gaming video here that the video RAM is actually dynamically adjusted to use as much as is needed, as it's showing using close to 4 gigabytes here. And here's a quick summary of the FPS results from these gaming benchmarks: Batman Arkham Knight, Forza Horizon 4, Hitman, Shadow of the Tomb Raider, and Sleeping Dogs. And this number here represents the average FPS for that specific benchmark. The darker region represents a 1% low FPS. Games with lower end requirements, of course, play very well. Terraria, for example, maintained a solid 60 FPS at 1080p. This game is, of course, not real taxing graphically, so it should be a pleasant experience overall. Minecraft Java Edition ran remarkably well, although I just ran around on the surface for a bit, but it did maintain a solid 80 plus FPS throughout. Now, I don't really play League of Legends, but I do get requests frequently asking how well certain systems can play it, so I just go through one of the tutorial lessons, and for what it's worth, this machine had actually maintained about 100 FPS at 1080p full screen. And for what it's worth, here's a couple of 3D Mark benchmark scores. Here's Firestrike, and here's TimeSpy. So next I went to install Ubuntu, and it went through without any issues. And you can see here we've got system details, and we've got the 12th Gen Core i5-12450H, 24 gigs of RAM, and I installed it on a separate SSD, so I pulled off the stock SSD and installed a different one. Then I also have the SK Hynix P41, as well as that mini SSD in the Wi-Fi slot. I'll swap that out to make sure Wi-Fi works in Ubuntu here as well in a minute. Go ahead and take a look at network. There we're connected at 1 gigabit Ethernet. We do have internet access. Go over to Firefox, go to YouTube, and everything seems to be like it's loading just fine. Displays, here it's showing 60 Hz and it can go up to 100 Hz. This display is capable of 1080p 100 Hz, and it's showing 100 Hz here just fine. In Windows it was actually only showing an option of 75 Hz. Not sure why that is, but it works perfectly fine here in Linux. Sound seems to work.
Front, left. Front, right.
So I also ran some quick benchmarks in Ubuntu using KDiskMark, which is similar to Crystal DiskMark in Windows. And I tested the M.2 slots as well as the USB ports. And you can see the comparison here between Ubuntu and Windows. and for some reason in Windows it is running much faster than it is in Ubuntu. And for example, the SK Hynix P41 here, we got 5481 megabytes per second read in Ubuntu, but 7071 megabytes per second read in Windows. And similar goes along with the right side of things too. Now when it came to USB and the MP600 Mini and that Wi-Fi card slot, those were very similar. And the stock SSD also ran a little bit slower as well, so I'm not sure why that is, but those are the results. 4K streaming content from YouTube was perfectly fine, and it had very few dropped frames. It was very smooth. And in Linux, it was hovering around 20 to 22 watts while playing 4K content, compared to Windows, which I think was about 15 to 16 watts. Because this machine has an Intel CPU with an integrated GPU, its quick sync video capability should make easy work for things like transcoding Plex media. Just to test this out while in Ubuntu, I fired up 4 4K videos and transcoded them each to 1080p, and I handled them just fine without any lags or buffering or skips, all while only utilizing about 20% CPU. And with the dual M.2 slots, it offers the potential for added capacity for hosting a small Plex server library. Next, I decided to disassemble the device to get a closer look at the other side of the motherboard where the CPU and RAM should reside, and also get a closer look at the power supply. I would have to say that I do not necessarily recommend going through this process because there are a lot of parts that need to be removed, including partial disassembly of the power supply, which could be dangerous. So there's 3 screws that need to be removed on the motherboard here, one right here, one right here, and one right here. And there's also this standoff here that needs to be removed with a socket wrench. Additionally, you need to remove this daughter board and also the power supply here. So we'll go ahead and take a closer look at the power supply. Now to remove the power supply, you can see that there's 2 screws right here, and then this pops right off, just like that. Now once you remove this lid, there's a shroud that you have to pull up. Then you can see here you've got this little pad here, and then there's 2 more screws that need to be removed. Now this can pull right up, exposing the power supply. And this whole guy comes right out. There's a 2-pin connector here. I'm nervous. So here's a quick look at the power supply. There's the PCB for it. Then of course you have your capacitors here, and then the 2-pin power supply here. Not a whole lot to it, but that's supposed to be able to provide up to 85 watts of power. Now once the power supply is removed, you can also remove this daughter board here. So there's 2 screws. There's one right here, and then one underneath this cable here with this foam pad over it. So that lifts right up, and then you've got to remove this little guy here. There's 2 little screws, and then this can just peel right off. So there's the daughter board. Now that should give you access, once you remove these 3 screws here, to remove this whole motherboard. Oh, and also you have to remove this post right here, which is looks like a 3.5 millimeter right there. And then you also have to remove these 2 screws right here for the power supply connection. Then that should just pull right out. There we go. Now we should be able to get the motherboard out. There we go. Now be careful because I have the Wi-Fi card still attached. I forgot to remove that. We'll just go ahead and take a close look at the underside here real quick. All right, so that's a lot of effort to be able to get access to here, but there we go. There is the heatsink and fan. Now it's time to get this off of here. Looks like there's 3 screws for the fan, 1, 2, and 3. Well, this looks like a pretty straightforward design. There's your heat pipes that are over the CPU, and then this looks like this is your actual RAM modules there. You can see here that the part number for the RAM is 2XB77D8CCP-PU032. Now, I wasn't able to find a whole lot of information about these chips online, but I did come across the synapse.com website. It looks like it is a Micron chip, And you can see here it is model number here with the part number D8CCP, which was also on the chip itself, LPDDR5, and 12 GB RAM modules. Then 5 more screws need to be removed that holds down the heat pipe assembly. Once I got the heat pipe assembly off, the thermal paste had a somewhat metallic glint to it, so I'm not sure if it was a conductive or phase change pad, but I was extra careful to remove the thermal paste without getting any on the main board itself, in case it happened to be capacitive or conductive of some kind. So here's a closer look at the CPU all cleaned off. Not much to see there, but you notice this pad here is kind of loose. It kind of lost its adhesion once I used some alcohol to clean the CPU. And then here's the heat pipe. I then proceeded to replace the thermal paste with a phase change thermal pad, PTM7950, which is supposed to be good for low pressure heatsink attachments in a device like this. Once I got it reassembled, I ran Cinebench R23 to see if there were any thermal improvements. Now before we go ahead and take a look at the repaste results, I just wanted to show you the actual benchmark results of Cinebench here. You can see at the top is the Beelink EQi12, and there's the resulting multi-core and single-core benchmark results compared with a Ryzen 8845HS, AMD Ryzen 6600H, and a desktop Intel i3-10105. So now here we have the results of the Cinebench R23 stock versus repaste. Now I know that this chart probably looks pretty busy, but I'll go through this real quick here. And over on the left, you have the scale for the CPU usage in percent in orange, CPU temp degrees Celsius in green, and CPU power watts in yellow. And then your actual core clocks are over on the right here, and that's indicated in blue. And then what you see down here is whether the thermal throttle flag had been triggered at this point in time in the benchmark. So first up, we go ahead and take a look at core usage. The solid line represents the stock profile. The dotted line represents the repasted profile. And so you look at the core usage, it's all pretty much pegged the same at 100%, with a little blip there in between transitions to a new test. The green represents the temperature of the core of the CPU, and again, solid green is the stock, dotted line is the repaste, and you can see there's not a whole lot of difference between those two there. And same thing with the core clocks, and also with the CPU package power. Seems like it starts to thermal throttle right about this point on the stock, and not much long after on the repaste. So ultimately, it seems like the repaste really didn't help at all. Now I wish I had done this prior to repasting the CPU, but I forgot about it. But I did after repasted, went into the hardware monitor here in the BIOS, and I changed the smart fan function from automatic both to full-on mode, so fans running at 100%, and then also I ran it under manual mode and setting the manual PWM setting to 127, which is effectively 50% fan speed, and I recorded the performance and temperature difference in both of those. So here's the resulting comparison of Cinebench R23 stock setup versus fan at 50%. And you can see that the CPU usage delta is less than 1%, so nothing substantial there. When we get to the CPU temperature itself, the average difference is about 2.3 degrees Celsius. You can see here the dotted line represents the 50% fan profile, so it's actually ramping up a little bit more slowly temperature-wise than it would at stock, although you can see the stock thermal throttles at this point, and the 50% fan profile here, it actually starts to thermal throttle after about 5 minutes. And then we look at the total clock speed, and the difference is about 93 megahertz. You can see here that it seems to maintain consistent like 2800 megahertz with the 50% fan profile, whereas it drops a little bit lower with the stock fan. Then we go ahead and take a look at the TDP of the CPU. Your change in watts is about 2.8 watts, and at least with 50% fan profile, it seems to maintain that 35 watt profile all the way through, whereas it tends to drop here once it starts to thermal throttle with the stock fan profile. Now when we boost that up to 100% fan, again, your CPU usage difference is pretty much negligible. And in this case, though, you can see that your delta T, your change in temperature average, is about 15 degrees Celsius. So that's pretty substantial. And as far as clock speeds, again, we're only about 100 megahertz difference. And then when we look at the total CPU TDP wattage, that's a difference about 2.8 watts. And again, it was able to actually maintain 35 watt TDP throughout the test, and as opposed to it dropping off here in the stock fan profile. And when running with 100% fan profile, the CPU did not thermal throttle at all. And another thing to note is based on this, it looks like that the CPU has been tuned to a 35 watt TDP, despite the specs for the CPU indicating that it is a 45 watt TDP CPU. But of course, one trade-off with lower temperatures is higher fan noise, and we'll take a look at that in a second. But first I want to go ahead and show you the Cinebench R23 benchmark results actually with the different fan profiles. The stock fan profile was 7588. Once we repasted, we actually got a slight bump in improvement, so I guess it did help a little bit. And then when we ran the fan at 50%, it actually went up a little bit more, and then at 100% actually gained a little bit more performance there as well. So it seems like it actually does help a little bit because it reduces that thermal throttling. Now additionally, I also ran handbrake, and I just wanted to show you the results of the handbrake test here. This is the Beelink EQi12, these charts right here, and the lighter color represents using the QuickSync versus the darker color, which is just using the CPU. And comparing that with several different CPUs, and of course AMD actually uses something called VCE, so it's similar to QuickSync, but it's AMD's own representation of the same type of hardware acceleration for video encoding. And like with Cinebench, I also ran some benchmarks of the different fan profiles using handbrake. You can see here that the stock profile was 789 seconds. Now in this case, the smaller number is better because it completes the operation more quickly, and the repaste was 737. Now the weird thing is 50% fan, it actually increased the amount of time it took to complete the task, whereas once I bumped it up to 100% fan, it actually completed it more quickly than any of the others. Now because we saw a significant drop in CPU temperatures with the fan at 100%, then only a marginal improvement at 50%, we can always go into the BIOS to the hardware monitor, right, go to the smart fan function, and then you can actually set the fan off, fan start, and the fan full speed temperature limit, fan start PWM. So in this case, you might want to go to something like 70 degrees at full speed, and maybe 50 degrees to start PWM. Then I would just leave it at like 1 PWM slope. Now I really haven't tested this much, so take that with a grain of salt, just saying that there's a way to tune this so that you can actually have a quiet running system when it's more or less idle, and then the fan can kick in to keep the temperatures cooled if you'd like to, at the expense of a louder system. Now just to get an idea for the sound of the fan, I'm going to leave the decibel meter here as well as the microphone so you can kind of get an idea for the fan noise difference between stock, 50%, and 100%. And lastly, I decided to perform a clean installation of Windows 11 Pro using Microsoft's download tool to a USB flash drive. The Windows installation went perfectly fine, no issues along the way. After I went through the gamut of Windows updates, there were still several unknown devices in Device Manager. So I headed over to Beelink's website to see if I could grab the drivers. Beelink does provide drivers at their website. If you just go to the support link, and then you can see here EQi right here, and then you can see the driver folder, and then there's the EQi12, and then there's the file name. It's a little bit of a slow download, but they do provide it. After I downloaded the driver file, I extracted it, and it put all the different drivers into individual folders. I went through and actually zipped each individual folder so that I could upload them up to VirusTotal just to scan for viruses real quick. And I had to do them individually because it has a 650 megabyte limit per file. You can see over here at VirusTotal, it's got completed scanning, and you can see everything came back completely clean. Now with the drivers in hand, I first ran the chipset driver installer, and that took care of all but one of the unknown devices in Device Manager. The last one, I pointed it directly to the serial I/O folder, and it found the driver and installed it immediately. And after updating all the drivers, I did a quick check and I could get on the internet. The audio seemed to be working fine. The SSD performance was fine. So everything seemed to be in good working order. And Windows 11 Pro was also activated immediately without any problems. The Beelink EQi12 is an interesting option in the world of mini PCs. It offers a system powerful enough to manage any daily desktop tasks you can throw at it, all while remaining very quiet. However, any kind of extended high CPU usage workloads will tend to thermal throttle the performance a bit. This can be offset by revising the fan curve in the BIOS, but this of course will result in higher fan noise while at load. And I'm just curious why Beelink didn't fine-tune it a little bit out of the box, because I think it's pretty understandable for a system at load to make a little bit of fan noise. The internal PSU is an interesting addition. However, I'm not sure I like sacrificing SODIMM RAM slots for an internal PSU, although at least they give you 24 gigs of fast DDR5 RAM suitable for such a system. Its integrated GPU is adequate for desktop use, but don't consider this machine if you intend on gaming with anything but lower spec options like Terraria, Minecraft, or League of Legends. Now, the inclusion of dual PCIe 4.0x4 M.2 SSD slots offers a storage expansion path. Now, the only thing that I really would like to have seen was inclusion of 2.5 gigabit Ethernet ports instead of the 1 gigabits that they gave you, and also a display port in lieu of a second HDMI port. So overall, I hope you found this helpful, and until next time, talk to you later.